Hello everybody, this is Coach Knight one more time. Today we're going to be talking about vectors in 3 dimensions. So if you watched the video where we did 2 dimensions, this is basically going to be a repeat of that, but we're going to be dealing with 3 dimensions. So not only x and y, but we'll also have a z in these problems. So basically, here is the vector form. So if you have a point A and a point B, to get vector AB, you would do the x2, x's minus x's, y minus y's, z minus z's, basically. Again, you want to make sure that if you're going from A to B, that you subtract the B components minus the A components. Okay, if you do it the other way around, your vector will not be correct. So again, basically you're just doing x2 minus x1 right there, y2 minus y1, z2 minus z1, and that would be your vector. And then to get the magnitude, which is also the distance formula, the distance formula that we're used to is just x minus x2 minus x1 squared plus y2 minus y1 squared, and take the square root of that. However, in 3 dimensions, you'll also have to do z2 minus z1 squared. So basically you're just doing it just like 2 dimensions, you're just adding the 3rd dimension in there. So these problems won't take that long. There's only 2, and we'll show you how to do them right now. So here we go. The first example right here says write the ordered triple that represents the vector from x, 5, negative 3, 2 to y, 4, negative 5, 6. Then write the vectors as the sum of unit vectors. So I'm also going to find the magnitude. It didn't ask to, but just to show you how we're going to. So first, find the vector. So we got vector x, y will equal, and again, we're just doing x2 minus x1. So the second x is 4 minus the first x is 5. The second y is negative 5 minus the first y is negative 3. And the third, or the z, the second z is 6 minus the first z is 2. And again, that's x1, y1, z1, x2, y2, z2. And again, after that, you're just plugging into the formula. So vector xy will be negative 1 and negative 2 and 4. That is vector xy. And that is known as an ordered triple. When it's just 2, it's an ordered pair. When it's 3, it's an ordered triple. So to get the magnitude of that, we would take the absolute value of vector xy. Okay, remember, absolute value bars is how they represent magnitude. So we're just going to take the square root of our vector, which was negative 1 squared, plus negative 2 squared, plus 4 squared. And we add all of that up. Negative 1 squared is 1, plus negative 2 squared is 4, plus 4 squared is 16. That will be the square root of 21, which cannot be reduced. So the magnitude of xy is the square root of 21. And then when it says to write it as the sum of unit vectors, remember that's always pretty simple. You just take the vector itself. Remember vector I is 1, 0, and since we're dealing with 3 dimensions now, you'll add another 0 on the end. Vector j is 0, 1, 0, and now we have a vector k for the 3rd dimension. It's 0, 0, 1. And so understand what vector I means. You go 1 to the right and you don't go any in the y or z direction. J means you go 0 in the x direction, 1 in the y direction, 0 in the z direction. K, 0 in the x direction, 0 in the y direction, 1 in the z direction. So basically, you just take I, j, and k and you put them up with the vector. So if we have vector -1, -2, 4, and we wanted to write that as the sum of unit vectors, we're just going to say -1 times vector I minus 2 times vector j plus 4 times vector k. And that would be the sum of unit vectors. All right. Another example you may have to work is algebraically working with your vectors. So here's another problem. It says find an ordered triple that represents 3 times vector p minus 2 times vector q. And it tells you what vector p is, and it tells you what vector q is. And basically, you're just plugging in here. So 3 times vector p is 3, 0, 4. Minus 2 times vector q is 2, 1, and -1. And like I've said before, you're basically just distributing your number on the outside times the vector. So that would be vector, that's going to be 9, 0, and 12. And now when you distribute your -2, this becomes a plus if you distribute the whole number. Like, you can distribute just the +2 and leave it minus, but I like distributing the whole thing and then you just make it plus. So -2 times 2 is -4, -2 times 1 is -2, -2 times -1 is +2. And then you just add your components up. So the x's add together, 9 plus -4 is 5, 0 plus -2 for the y's is -2, and 12 plus 2 for the z's is 14. And there is your vector. All right, hope these problems helped, help you with your studies, help you understand 3D vectors a little more, and hope y'all have a great day. As always, stay above the line.